Problem 8. We need to find out the value of load resistance RL to get maximum power from the source, and also I need to find maximum power at load. I am following maximum power transfer theorem. I need to remove this load resistance to get open circuit voltage. So this is the same circuit, R has been removed. So this is VOC, open circuit voltage. The rest parts are same. What is VOC? VOC is potential at this point A with respect to B, that is VA minus VB. So VOC is equal to VA minus VB. Now what is VA? As this is ground, VA is potential at this point A, that is voltage drop across this 30 ohm resistance. How to find voltage drop across this 30 ohm resistance? It is the multiplication of this 30 ohm and the current flowing through this 30 ohm. So what is the current? This current is produced due to this source. So this current will be equal to this source 180 divided by the full path resistance, that is 180 divided by 10 plus 30. So this is the current flowing through the 30 ohm resistance, that multiplied by 30 ohm, this is potential across this 30 ohm resistance, which is VA. So this is VA. Now what is VB? Similarly, VB is the potential across this 40 ohm resistance, that will be multiplication of 40 with current flowing through the 40 ohm resistance. So again from this loop, what is the current? Current is, because of this 180 voltage, so 180 divided by full path resistance, that is 20 plus 40. So this is the current flowing through 40 ohm resistance, that multiplied by 40 is the voltage across 40 ohm, which is VB. So this is VB. So VA minus VB, ultimately it is 15 volt. So open circuit voltage, that is VTH, which is 15 volt. Now trying to find out the RTH. For RTH, removing this load, say I have removed it, source voltage will be replaced by their internal resistance. Here the voltage source, no resistance has been mentioned here, so it will be considered as ideal voltage source. Internal resistance is 0, so it will be shorted. So this is short. So this is ultimately the resistance combination to get RTH. If it is difficult to understand which resistance is in series or parallel, you may redraw this resistive combination into a simpler one. Say I am starting from A, so this is point A. It is having two paths, 10 ohm and 30 ohm. So redrawing it with two paths, 10 ohm and 30 ohm. This is 10, this is 30. It meets at a particular point. This point and this point are same point. This point are same point. So from this point, I am again getting two paths. One path is this 20 ohm, another path is this 40 ohm. So from here, I am getting two paths. One is 20, another one is 40. So this is 20 ohm, this is 40 ohm. These two again meet at a particular point, and from that point it is B. So this is equivalent of this resistive network in a simpler way. Now it is very easy to understand that 10 and 30 are parallel, 20 and 40 are parallel, and equivalent of this one and equivalent of this one are in series. So ultimately from this I got 20.8 ohm, this is RTH. So putting RTH and VTH in equivalent circuit, this is that equivalent circuit. RL is load. To get maximum power at load, the value of this load resistance should be equal to this source resistance, which is RTH. So see, load resistance here it is 20.8 ohm. Now using this formula Pmax, open circuit voltage square divided by 4R, ultimately I got maximum power at load is 2.7 watt. Now checking whether my calculation is perfect or not. See, this is equivalent circuit, 15 volt VTH, 20.8 ohm RTH, and load resistance is same value, 20.8 ohm. In main circuit I have used load resistance as 20.8 ohm. Now if I get power at load 20.8 in main circuit and power at load 20.8 in equivalent circuit are same, and which is equals to this 2.7 watt, then it will be confirmed that whatever the calculation I have done, that is perfect. Now running the simulation. See here, in main circuit it is showing 2.7 watt. In equivalent circuit also it is showing 2.7 watt, that is maximum power at load. So my calculation is perfect.